So now we have three more columns. One is the marital status, one is gender, and one is age. Okay. In age, we can treat this as a continuous value, and maybe you can just go and replace with the mean or any design value that you want to choose. So if you want to look at the overall data as the consolidated one, so I'll just go and say employee data dot. There's something called as describe. Okay. And when you say describe, what it will do is it will try to fetch all the continuous values and it will show a couple of features like what is the count, what is the mean, standard deviation, what is the min value, what is the max value, and what is the median, and what is the value at 75% quantile and 25% quantile. So now we are concerned about age. So let us go and see how age looks like. So we're concerned about age. So we'll go and see at age. So if you notice, age is like the mean value is 32. Okay. And the median is around 29. Somewhat close. Okay. It was little away from the 50th percentile. So whatever value is sitting at 50th uh, quantile in the distribution, that is called as a median. So I'll discuss more about this mean median values in couple of sessions later on. But for now, let's say whenever you have a continuous feature and you do not know what to which value to choose from, you can always go with the mean. Okay, provided that the mean and median are almost same. They need not be exactly equal, but they should be almost similar. Okay, in this case, it is almost okay. So what I'll do is I'll just go and replace with the median value. So what is my median value is 29. So I'll just go and replace with the median value. So what all the null values that are present in my age will now be replaced with 29. Similarly, if there is any null values in marital status, I'm putting it as unmarried. And in gender, I'm putting it as male. Why I'm putting it as male is because the number of count for male is pretty high. And there is nothing much you can do. Okay, you can either try with male and or else you can try with female. Okay, this we have already completed. And we have one more feature. Say now let us go back and find out what are the null values present in our dataset. Yeah. Let me copy this. Don't need this. After describe, we have done that. Let us go and find out what are the null values present in the dataset. Now, when I go and see it, there is only a couple of columns now we are left out with. One is the last evaluation, one is satisfaction, one is tenure. Now, tenure is also a categorical feature because it says how many years a person has worked. Okay. And it will be defined like some people can work for 2 years, some people can work for 3 years, and it has defined it. Say, for example, in this case, let us go and see what are the different values for tenure. Say dot value underscore counts drop NA is equal to false. Okay, null values are like 1487, and you notice, sorry, it's not last evaluation, it should be looking for tenure. Yeah. So tenure, you can see that there are different set of values. A couple of 3s, 2s, 4, 5, 6, 8, and most likely this is some other value, right? So what we can do is we can also replace with the mode here. Like most frequently the value is 3000. Sorry, so the value is 3. So we can go and replace this value with 3. Or else
Yes.
by looking at the data, you see that there is no one value here. Maybe you can also try it with 1. Just given a case that if you want to try with 1, we can also try with 1. When we're coming with last evaluation, we can notice that the mean is 0.71 and the median is at 0.72. So here also in this case, we can replace with median value. So what I'll do is I'll just go and get the median based on department. Now, for example, every feature, now this is the for whole column. Last evaluation, it's complete column. It doesn't bother about which department the record belongs to. Now, what I want to do is I want to find out the median for each individual department. So how do I do that? So I can just create a new column called LE underscore median. Okay, last evaluation underscore median. And what I'll do is I'll do a group by on department, and I'll look at last evaluation column and get its median value by doing this. When I use dot transform, I don't have to create a new data frame. It'll go and create a new column within the same data frame. Okay. So when I go and say this, dot head. See, even if you don't understand this, don't worry about it, because as you keep practicing this, it'll get very, you'll get used to it, because these are all very important in the pre-processing stage. So what I'm trying to do is, based on the department, I want to fetch what is the median value for each department. Now we have like 10 departments, right? The median value for worker category could be different. The median value for an admin department could be different. The median value for an IT department could be different. So I cannot consolidate the whole company's median value in all the null values. So based on the null value for a given department, I'll go and replace with the respective median of that particular department only. So in this case, the department is PD. That is why you see that 0.732204 is the median value. Wherever it is PD, you will find this value. So dot transform we will generally use when we want to create a new column by doing group by. As I said, group by, what it will do, it will try to remove all the duplicates and it will create an index. Okay, here also it is doing the same thing, but when you use transform, it after it does that, it applies all the same values to respective departments. Wherever this department is matching, that respective median will be coming. Here you can also use dot sum or dot count or whatever, whichever function that you want to use, you can use a dot transform based on that particular function. Okay, and you see that the number of records will not change, it will remain same. We have 14,150 records. Now, what I said, like based on the department, I want to go and replace the null values, right? So just moments ago, I told you how to use dot log and copy a value from one different column. So I want to replace the last evaluation column with the value from LE median. So what I'm going to do, I'm going to use dot log. I'm going to put a condition. The condition is wherever last evaluation is null. This is my condition. Wherever last evaluation is null, I want to replace the values present in last evaluation with the values present in LA median. So you have the same condition on both sides, but different column on the left and different column on the right. This is the column where you want to replace. This is the column where you want to copy from. Okay. Now when I do that, let me go and drop LA median. Okay. Now after doing this, I'll just go and see what is my number of null values now. Let's say, just notice how many null values we had here. In last evaluation, we had 1,487, right? Now let us go and see how many null values that we have here. We have dropped it. After dropping it, I'm going to place new one and see what are the number of null values. Still, there are 150. Okay. Why there are 150 values? Because it did not get any department to get, say, for example, all the records for that particular department, there is no last evaluation. Okay, but that particular department, they don't have any last evaluation. So in this case, you can go and replace the company's quantile. So what company's median value. So how to get a median value is by using NumPy. You have something called as NaN quantile. Even when you have null values, you can consider that particular feature. Like in this case, this is my Panda series. I'm going to take the 50th quantile. What happens in when you do this is you will you already have a Panda series, right? Series is nothing but a list, as I told you. Okay, you have n number of values like this. So first, what it will do is it will try to sort them. After sorting it, again you will have the same shape, but the values are in increasing order. Based on the number of count, you'll get the center value, wherever is the center value. So n by 2 is the value that you'll get. If the n is like odd number, maybe you'll have to plus 1 and then divide it by 2 to get the center. And once you get the center, that center value is nothing but your quantile value, 50th quantile value. This is my median. In other cases, what you can do is you can also use describe. So what I'll do is I can achieve the same part by doing employee data last evaluation dot describe. So when I do it, you can notice the medium value is 0.0728827. That is what you have, 0.728827. You can use any of the values. This is the quantile way of getting it, 50th quantile, or you can use dot describe and get the 50th quantile. Okay. And then what I'll do is wherever again still have last evaluation as null, I'm going to replace it as 0.5. Now I went and replace it. Okay. Now you should not see any null values in that particular column. Now, after doing this, let's go back and find what are the other null values that are present in the data. Just a couple of more minutes. Should be done with this.
Satisfaction.
Yeah, we have satisfaction and tenure also. So we are left out with satisfaction and we are left with tenure. As I said, like tenure, satisfaction also, you're going to do the same thing like what we did. So in this case, I'll simply go and replace with the 50th quantile. See, on the right side, we have a static value, okay? NP and quantile satisfaction, get the 50th quantile and replace wherever is the null value, go and replace with this particular value. And similarly for tenure, it is not a continuous data, it is a categorical data, okay? But just in case if you want to look at the describe part of it, you can see the 50th quantile is around 3 because most of the values are around 3 only. So what I'll do is I'll just go and replace the values as 3 wherever I have null values. This is not a continuous column, this is a categorical column. Just keep that in mind. We have defined number of experiences that are falling in the category. Either you have 1, 2, and so on to 10 years. Maximum we have 10 years. Okay, and an employee can belong to any of these categories. That's all. And when you go and find out what are the other null values, see all the null values you have to read it. So when you're dealing with null values, you have to make sure that you pick one column at a time, analyze that column in every possibility that you can, and then go and treat it based on couple of things. Like you can replace it if it is a categorical data. The first obvious choice is go and replace with mode, or as I did, right? Look at the data and try to find out if there is any other feature that you can replace it. Or if the number of null values are too high as compared to the categoricals, maybe you can create that null values as a new feature. Say, for example, I had departments like 10 departments, okay? When I look at the data, like you had SS department and then you have like PD department and so on, okay? This was having some count, this was having some count. For example, your null values, wherever you have null values, you had very high count. Say, for example, like out of 14,000 records, maybe 4,000 records are null, for example. In this case, because the number of NaN is pretty high as compared to individual count of a department, here you should treat this 4,000 as some new category or a new department which is not there in the data. So try out different possibilities and then see how the model is performing. So if you treat it as a different department, what is a model performance? Or if you treat it with a mode value, what is a model performance? So you have to try out n number of possibilities and then come up with some conclusion. If your model is good, it is good. Then you don't have to worry about changing any other thing. But until you reach to that point where the model is not performing well, you have to keep trying all these possibilities. Any doubts so far?
An example, tenure we have, I mean, more to 3 years tenure. So instead of that, 1 year, 2 years, something like, can we divide into multiple tenures?
But yes, you can divide into multiple tenures. Say, for example, if you want to say, I want to keep couple of records as 1, couple of records as 2, couple of records as 3.
So,
the thought is good. I agree. The thought is good. But what is the logic behind putting this 1? What is the logic behind putting this 2? And what is the logic behind putting this 3?
because we don't know we don't know how many people joined 1 year ago, 2 years ago. At least it would be average, and the mean and the median would be definitely match later on.
Correct. So in this case, the median value is 3. That is why I have kept 3. Okay. But if you want to
Yeah.
try it with 1, 2, or 3, we can try with only one value. Say you want to try with 1,
Okay.
you go and try with 1. Try with 2, you can go and try with it. But don't try to create more problems, because there is already some noise that you're trying to clear it. Okay. You have like a very large number of records that are null. You're treating that, you're cleaning the data. The way
Yeah.
the value which you're putting, it need not be correct. Okay. It need not be correct. The actual truth we don't know. That particular record, it
Exactly.
might have belonged to a candidate who has spent 5 years in the company, but we are going and putting it as 1. It might be wrong, but we cannot go and drop also, right? If you drop it, maybe there is some underlying patterns of those records, so we should not drop it. So the obvious thing is, go and try with 3. If you want to go and try with 1, it is also okay. Always measure the impact. Okay. When I say impact, you notice that here we had 150 records, correct? 150 null
Yeah.
values. So if I say 150 divided by 14,150, it is hardly 10%. It is hardly 1%, not even 10. It is just 1% of the data.
Yeah.
If your gut says that I don't lose by dropping this records, you can go and drop it.
Okay.
Or if you
But
want to
we
go and
cannot keep
replace,
it in multiple tenures. We
don't
can
keep
keep
it in
it in
multiple.
any one tenure.
Keep
Oh,
it in one tenure, because if you keep it in multiple tenures, you're spoiling the data to a larger extent. There is already noise in the data, and
okay.
you're creating it more problems for yourself. So go with one particular value and then try to save. Or what you can do, based on the department where that record belongs to, try to get the average tenure. You can do that.
Oh,
Okay, so 150 records might be belonging to different departments, right? So each department, what is the average tenure? You can take that average tenure and replace it. That you can do.
oh. Yeah. That is again more work.
Correct. So we should try as many possibilities as possible, so that when we go to a stage where we are applying models, then the model performance will be a little better. We are left with, now we have converted the cleansing part, but machine cannot understand text data. Say for example, if you go and look at the values, say if I have value like this, I have median, low, high, and this product sales. I don't The machine cannot understand these values. So in coming classes, we will try to identify how to convert this categorical data into numbers. So there are n number of ways of doing it. We'll take it that in the next session. Okay, but for now, in the pre-processing stage, I think we should be good. This is a very good data set for you to practice. Maybe like if you get some chance tomorrow, you can just try this out and come back if you have any questions around this.
Sure.
Okay,
Sure, Sanjay.
then yeah, then we should be good for today. We'll touch base tomorrow again.
Okay.
Okay.
What time?
In the morning only, preferably. Tomorrow I'm going to
Okay.
teach you about visualizations.
Okay.
I have
Plot.
couple of have made this ready for you guys, so we can just discuss this. My system has completely become slow all of a sudden. Okay, I have the session ready for tomorrow, so we can discuss about visualizations in tomorrow's session. Okay.
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 Thank you.
Thank you
Good
so
night.
much. Good night.
Okay,
Good night.
Sanjay.
Take
Thank
care.
you, Sanjeev.
Thanks a lot.
Thank you.
Thank you.